So now let's look at a confidence interval for means. We're going to be using now a T model, which we haven't really discussed in detail yet. I just sort of introduced it in the last video. We're going to actually use it in this to create a confidence interval for means. Now, before we actually create the confidence interval, just like last week, we need to talk about the assumptions and conditions. And so essentially, I'm just going to be testing those assumptions and conditions, which will be almost the same as they were last week. So the assumptions and conditions for means are almost the same as they were for proportions. We still have independence, we still have randomization, we still have 10%. But last week, when we looked at proportions, we were looking at a success-fail condition, and we don't have that for a means question because remember, we checked the success-fail condition by taking n times p and n times q, and we can't do that this week because there's no p and there's no q. So this week we're dealing with means, and so we need to check the nearly normal condition. Now there are several ways to do this. First of all, if we already know the data comes from a distribution that's unimodal and symmetric, then we're okay. If not, then we are looking for a sample size that is large as possible. So if I have a small sample size, so if n is less than 30, then T works as long as the data are unimodal and symmetric. So again, this is saying, hey, if n is really small, then you need to look at a histogram or a normal probability plot and make sure it fits that nearly normal condition. If I have a large sample size, then it doesn't matter what I have. So if I have n is greater than or equal to 30, then I'm going to be safe because that, remember way back when we talked about the dice and our population was uniform, but as I sampled 20 die, it looked very much normal. So let's take a look at the steps when I'm creating a confidence interval. First, we're going to check the assumptions and conditions and tell the model that we're using. And of course, this week, the model that we are using is going to be the student's T model. And the test that I'm using is going to be a one sample T interval and later a one sample T test. Perform my calculations. So remember last week, we had p hat in the middle because that was my observed value. And notice down here, I have y bar, and that's just my observed mean. And last week I had plus or minus, this week I still do. Last week I had a z star because I was looking for a critical value for the Z model or normal model, and notice this time I have a T star for a certain number of degrees of freedom, and previously I had the standard deviation, or excuse me, the standard error, which was p hat q hat over n, and this week I have the standard error, which is s over radical n. So here's how I would put it all together. Y bar plus or minus T star for the correct number of degrees of freedom times the standard deviation divided by radical n. And then the conclusion is going to be exactly the same as it was last week, same ideas. So again, you should at this point have opened your Statcrunch data. It should be within your video playlist. If not, you do, of course, need a Statcrunch login, but you should be able to navigate to the URL I have on the page. So what we're going to do is we're going to go through this first example together. And the first example says 10 randomly selected high school basketball teams scored, and then it gives me a list of 10 scores. Points in a game. Find a 90% confidence interval for the mean score of all high school basketball teams. Check your conditions and assumptions, then tell the model that you're using. So first I'm going to check my conditions. Independence. Points scored by teams are independent. Randomization, the teams were sampled randomly. 10%, 10 teams is less than 10% of high school basketball teams, and nearly normal. That's why I have Statcrunch open here, because I need to show you two different ways to check nearly normal. The first way, and again notice I have all of my basketball scores here in this column, And so the first way is to go to graph and histogram, and I'm going to choose the basketball scores column, and click compute. And looking at this appears to be nearly normal. I'm concerned it might be a little bit skewed because it seems to be a little heavy on the right, which means it's skewed to the left. If I'm not sure, then I'm going to go to graph and QQ plot, and again choose basketball scores, and notice I'm not messing with any other options. And this is a QQ plot, which is sometimes called a normal probability plot, and notice it has this nice red line for me. And what I'm looking for is I want my data to basically follow this line. So if I had data that sort of curved around, then I would be concerned. This doesn't concern me because it looks fairly straight. It doesn't look like there's really a pattern, and so I'm going to say yes, it's okay. So whenever you do one and you're concerned about it, always check the other. So again, I just went to graph and then histogram, and then I went to graph and QQ plot, and those are the two ways that I can check the nearly normal condition. And then again, because the conditions are satisfied, I can use the student's t-model to find a one sample t interval. So now that I know that I can use this model, I need to figure out a couple of things because I really don't have any information. I have a bunch of data, but I don't have the mean, I don't have the standard deviation, and I don't know what the critical value is. So we're going to do all of that together right now. So first, I have to find a critical value, and I've explained it on this page because we've already done the other thing, and I'm just going to show you that again as a reminder. But we've not done this before. This is finding a critical value for means. And last week we knew that if we're going to do a 90% interval, we always used 1.645. And if we were going to do a 95% interval for proportions, it's 1.96. Every time, we didn't have to look it up, we could just use the same values. But remember, the t model is different than the normal model. Every degree of freedom creates essentially a new model, so it's going to create different values. That means every time I do this, every time I create a confidence interval, I have to go into Statcrunch to figure out the critical value. So what do I need to figure a critical value? I need the degrees of freedom, and I need the percent of the confidence interval. Now I'm already given that it's a 90% interval that I'm looking for. The degrees of freedom is always n minus 1. So n in this case was 10 because I had 10 basketball scores. 10 minus 1 is 9. So I'm going to go to Stat, Calculators, and don't go to Normal. Normal's where we went last week for our Z model, our normal model. I'm going to go to T because that's what the model this week. And I'm going to change the degrees of freedom. I'm going to click on that between function, and I'm going to replace the probability over here with whatever my percent is for my confidence interval. So in this case it's a 90% interval. And notice it gives me negative 1.8331 and positive 1.8331. So the positive value, 1.8331, is the one I will use, and I typically round to 3 places. Don't round to 2 places, please. So that's the value that I'm going to use. Now before I move on to the next slide where we actually create this interval, I want to also show you how to find the summary statistics, which again, we've done this before, but I'm going to need to know the mean and the standard deviation of my data, and that's not given to me. I'm only given data. So I'm going to go to Stat, Summary Stats, and Columns because my values are in a column, and I'm going to choose Basketball Scores and click Compute. And again, I could have chosen different things that I wanted. I usually just do, the ones that are given to me. And what do I need here? I need the mean, which is 57.8, and I need the standard deviation, which is 6.014796. Those are the values that I'm going to be using. So now let's look at 2, which is to perform the calculations. Now, to perform the calculations, I would of course have to do my summary stats. I just showed you how to do that on the last slide. So just loading that data into Statcrunch and letting Statcrunch do all of the work for you. And then I also needed to find that critical value of 1.833. Again, we just went through that on the last slide. So now what I'm going to do is I'm going to look at using my formula, and remember my formula said take your mean, which is y bar, plus or minus your t star, and in this case for 9 degrees of freedom, and then I'm going to take that times the standard deviation divided by radical n. So this is what that's going to look like. 57.8 is my mean, 1.833 is my critical value, and this, all of this, is taking 6.015, which is what I rounded that to, divided by radical 10 because there were 10 values. Just like we did with proportions, I'm going to do everything here in one step in my calculator so that I don't do too much rounding, and that gave me 3.487. Then I'm first going to subtract that from 57.8, then add it to 57.8, and this gives me my interval. Now from here, this is all stuff we've done, so we know how to do all of this in our calculator, and we know how to write our conclusion. I'm 90% confident that, and then I'm going to use these two values, that the mean score of all high school basketball games is between 54.31 and 61.29 points. Now, just like before, it'd be really great if I could let Statcrunch do all of the work just to verify my work. And remember, you'll be asked to do this anyway when you take an assessment. So to verify with Statcrunch, and notice I've just copied the interval that I found by hand, what I'm going to do is go to Stat. And remember, last week we did this with proportion stats. This week we're going to T-stats. This time I have one sample, and this time I actually do have data because I'm telling Statcrunch that I'm going to choose one of these columns. So I'm going to click with data, and I'm going to click on basketball scores. And remember, I'm looking for a 90% interval, so down here I'm going to choose the radio button next to confidence interval, and I'm going to change that to 0.9 or 90% and click compute. And notice what it did is it created my sample mean, which is 57.8, which I already knew, my standard error, which is when they took the standard deviation divided by the square root of n, and then the lower limit 54.31, upper limit 61.29. And that matches exactly what I had by hand. So here's a question for you to try all by yourself. I'd like you to press pause. Check the conditions, create the confidence interval by hand, create the confidence interval in Statcrunch to verify your results, and then write a conclusion. This is dealing with a battery lifespan. They're hoping it's 300 minutes. They gave us 12 different samples of battery lifespans. I want a 95% interval for what the true proportion, or sorry, the true mean lifespan might be. When you're done, press play to check your work. So again, if I'm doing everything, and I tried to fit everything all into this one slide, so yes, it's small, but the first thing I would do is check my conditions, and again, randomization, we'll assume 12 batteries were chosen randomly. 10%, 12 batteries is less than 10% of batteries produced by the company. Independence, battery life for each battery is independent, and nearly normal, I just used my QQ plot and I wasn't too concerned with my results. Then I said, hey, the conditions are met, I'm going to use the student's T model to find a one sample T interval. Then I had to go about finding my values that I will use. So I did my summary statistics, again that's in Statcrunch, to find my mean. Obviously I'm going to use n, and I'm going to use the standard deviation. Don't cheat and go straight to standard error, you don't get all the points. And I also had to go into my T calculator and choose between, and use 11 degrees of freedom because I had 12 items, and 12 minus 1 is 11. And here I put in 0.95 because I'm looking for a 95% interval, and I got out 2.201. So that's where all of the values came from. So I used my mean, I used my critical value, I used my standard deviation, and I used n. I do all of those calculations to come up with 287.63, 324.87. So that's the lower end and the upper end of my interval. And again, I'm saying I'm 95% confident that the true mean lifespan of batteries falls between 287.63 minutes and 324.87 minutes. So again, this week we're dealing with means. Make sure that you're labeling. Now, my question might be is, how are we looking in terms of the 300 minutes? Well, 300 is in that interval, so I feel pretty good about the fact that it's 300 minutes. Now, if I'm doing a test and I want to see if it exceeds 300 minutes, then I should sort of know the answer already, but maybe we'll look at that when we look at test as well.